Hi guys, so this is another physics review. So today we're going to go over momentum, impulse, and collisions. So momentum is the product of an object's mass and its velocity, and it's a vector quantity, which means that it has both magnitude and direction. So the variable p stands for momentum, and the formula is p equals mass times velocity, and the units are kilograms times meters per second. So impulse is the change in momentum of an object, and the variable which it stands for is j. So there are many different formulas for impulse, but the main ones are F net times time and change in momentum. So I listed different ways you can solve for change in momentum. So you can do final momentum minus initial momentum, mass times final velocity minus initial velocity, or mass times change in velocity. So the units for impulse are either newtons times seconds or also just kilograms times meters per second. The law of conservation of momentum states that the total momentum of a system remains constant unless an external force acts upon it. So momentum is not created or destroyed, but just changed based off of forces. So some examples of collisions are just basically when objects collide with each other. So for example, if there's a car crash, the total momentum of the cars before the crash will be equal to the total momentum of the cars after the crash. So now let's talk about some different types of collisions. So the first one is going to be an elastic or like a bouncy collision. So in this type of collision, the objects will bounce off of each other. Now, m equals mass, v equals velocity, I equals initial, and F is final. So the formula here is going to be m1v1i plus m2v2i equals m1v1f plus m2v2f. Now, our second type of collision is going to be an inelastic or like a sticky collision. So it's called a sticky collision because the objects in the collision stick together after colliding. So the masses of the objects will combine. The formula is going to be m1v1i plus m2v2i equals m1 plus m2 times vf. Note that in the final part of that formula, since masses combine, we're just adding the masses. Now our third type is going to be a recoil / explosion / push apart collision. So basically in this type of collision, the objects start at rest, which is why the initial momentum is 0. So the formula for this type of collision is going to be 0 equals m1v1f plus m2v2f. So now that we understand the concepts, let's do some multiple choice practice. Number 1. A 1,200 kilogram car traveling at 10 meters per second hits a tree and is brought to rest in 0.1 second. What is the magnitude of the average force acting on the car to bring it to rest? So for this question, we need to find F net because the question asks us to find the force acting on the car. So the question gives us velocity and time, so we have to use the acceleration formula to find acceleration. So A equals V over T. So the velocity is 10 meters per second, and the time is 0.1 seconds, and that's going to give us an acceleration of 100 meters per second squared. Now we can plug that in to solve for F net. So F net equals mass times acceleration, 1,200 kilograms times 100 meters per second squared is 1.2 times 10 to the 5th newtons. Number 2. In the diagram below, a block of mass, capital M, initially at rest on a frictionless horizontal surface is struck by a bullet of mass, lowercase m, moving with horizontal velocity v. What is the velocity of the bullet block system after the bullet embeds itself in the block? So, in order to solve for the velocity of the system after the bullet collides and sticks to the block, we need to use the inelastic collision equation, which is m1v1i plus m2v2i equals m1 plus m2 times vf. And then we have to isolate the variable vf. So we have to put this formula into the terms of the question. So I'm going to say that m1 is the bullet and m2 is the block. So we can write this as lowercase m times velocity, and the block, uppercase m, is initially at rest, which means that its momentum is going to be 0. So we could just do plus 0. And this is all equal to lowercase m plus uppercase m times vf. Now, to isolate vf, we have to divide lowercase m plus uppercase m on both sides. So VF is just going to be equal to MV over lowercase m plus uppercase m. And if we look at our answer choices, this is equal to B. Number 3, when a 1 kilogram cart moving with a speed of 0.5 meter per second on a horizontal surface collides with a second 1 kilogram cart initially at rest, the carts lock together. What is the speed of the combined carts after the collision? So this question is asking us for the final velocity of the system after the collision. It tells us that the carts lock together, so this is a sticky, inelastic collision. To find final velocity, we can use the equation m1 v1I plus m2 v2I equals m1 plus m2 times vf. And we just have to plug in. So m1 is going to be the 1 kilogram cart that's moving at 0.5 meters per second. And the second one is going to be the 1 kilogram cart at rest, which is just has no momentum. So that's equal to 0. And then everything is going to be 1 kilogram plus 1 kilogram times VF. So this is going to be 0.5, which equals 2 kilograms times VF. So VF is going to be equal to 0.25 meters per second. And that is choice C. Number 4. A 5 kilogram cart moving with a velocity of 4 meters per second is brought to a stop in 2 seconds. The magnitude of the average force used to stop the car is what? So this question is similar to number 1. It's very simple. We just solve for F net. So it doesn't tell us acceleration, but it tells us velocity and time. So we're going to do 4 meters per second over 2 seconds, and that's going to be 2 meters per second squared. And then F net equals MA. So 5 kilograms times 2 meters per second squared is 10 newtons. Choice C. Number 5. The magnitude of the momentum of an object is 64 kilograms times meters per second. If the velocity of this object is doubled, the magnitude of the momentum of the object will be what? So the formula for momentum is P equals mv. So if we double velocity, momentum has to double as well because it's proportional. So our answer is going to be 128 kilograms times meters per second because 64 times 2 is 128. Base your answers to questions 6 and 7 on the information below. Block A moves with a velocity of 2 meters per second to the right, as shown in the diagram, and then collides elastically with Block B, which is at rest. Block A stops moving, and Block B moves to the right after the collision. If the blocks had remained together after collision, their velocity would have been what? So, once again, we are finding the final velocity of the blocks after they collide and stick together. So for this, we use the inelastic collision equation. So m1 v1I plus m2 v2I equals m1 plus m2 times vf. So we just plug in. So the first block is 10 kilograms and it's moving at 2 meters per second. And then the second block is at rest, so that's equal to 0. Then mass 1 plus mass 2, so 10 kilograms plus 10 kilograms, and then we're trying to solve for final velocity. So this is 20, and that equals 20 VF, so that means VF is 1 meter per second. So our answer is going to be choice A. Number 7. If Block A is stopped in 0.1 second, the average force acting on Block A is what? So it's asking us to solve for average force acting on Block A, so we just solve for F net. And F net equals MA. We don't have acceleration yet, so we'd have to do 2 meters per second over 0.1 second, which is 20 meters per second squared. So, 10 kilograms times 20 meters per second squared is equal to 200 newtons. Number 8. In the diagram below, a 60 kilogram roller skater exerts a 10 newton force on a 30 kilogram roller skater for 0.2 second. What is the magnitude of the impulse applied to the 30 kilogram roller skater? So for this question, we have to solve for impulse using the formula J equals F net times time. And it already gives us force and it also gives us time, so we just plug in. So force is 10 newtons and time is 0.2 seconds. So this is equal to 2 newtons times second. Base your answers to questions 9 and 10 on the information below. The diagram shows a compressed spring between two carts initially at rest on a horizontal frictionless surface. Cart A has a mass of 2 kilograms and cart B has a mass of 1 kilogram. A string holds the carts together. What occurs when the string is cut and the carts move apart? So the answer to this question is going to be choice A, and let me explain why. So when the string between the carts are cut and they move apart, the string will exert the same amount of force on both carts due to Newton's third law, which, if you don't remember, that's every action has an equal and opposite reaction. Emphasis on the equal. So this is why choice B is incorrect, because it says that the forces are going to be different. Also, since the force exerted on both carts are equal, but their masses are different, they're going to have different accelerations. Remember that the equation F net equals ma shows that if both carts have the same net force, but since cart A has a larger mass, the acceleration of cart A will be less than that of cart B, which is why choice A is correct. Also, C and D are wrong because momentum stays the same because there's no external force acting on the system, so impulse has to be the same for both carts. Number 10. After the string is cut and the two carts move apart, the magnitude of which quantity is the same for both carts? So the answer here is going to be momentum due to conservation of momentum. Number 11. A rocket with a mass of 1,000 kilograms is moving at a speed of 20 meters per second. The magnitude of the momentum is what? So this question is really easy. We just use the momentum equation and plug in. So P equals mv. So 1,000 kilograms times 20 meters per second is going to equal C, 20,000 kilograms times meters per second. Number 12. A force of 10 newtons acts on an object for 0.01 second. What force acting on the object for 0.05 second would produce the same impulse? So this is another easy question. It's asking us for impulse, so we use the impulse equation and plug in. So J equals F net times time. So J equals, it tells us a force of 10 newtons times 0.01 second. And that's going to equal 0.1. So what force acting on the same object for 0.05 second would produce the same impulse? So now we're going to plug in like this. So 0.1 equals, we have to find that force times 0.05 second. And the force F net is going to equal 2 newtons. So our answer is choice B. 13. A 0.149 kilogram baseball initially moving at 15 meters per second is brought to rest in 0.04 second by a baseball glove on a catcher's hand. The magnitude of the average force exerted on the ball by the glove is what? So this is another question just asking us for force, so we use F net to solve. So F net equals mass 0.149 kilograms times acceleration, which is 15 meters per second over 0.04 second, and that's going to get us 56 newtons. 14. If the speed of a moving object is doubled, which quantity associated with the object must also double? So obviously this entire unit is about momentum, so the obvious choice is momentum. But let me explain why it's right. So when you increase either mass or velocity, momentum has to increase proportionally because there is a direct relationship in the equation. Also, let's pretend that the mass of the object is 2 kilograms. So let's do a little example. So 2 kilograms, and let's pretend that the velocity is 2 meters per second. So that means our momentum would be 4. So let's double the speed. So we keep mass the same. Now the speed is 4 meters per second, and that means our new momentum would be 8, so it doubles. So I'm going to skip 15 and 16 because they're really easy. Just solve for force, which is F net. 17. A 2 kilogram ball traveling north at 4 meters per second collides head-on with a 1 kilogram ball traveling south at 8 meters per second. What is the magnitude of the total momentum of the two balls after collision? So first, let's find the momentum of both of these objects before the collision. So for the first one, we're going to do P equals mv. So 2 kilograms times 4 meters per second equals 8. And for the second ball, it's 1 kilogram times 8 meters per second, and that also equals 8. Let's look at the wording of this question. Remember that the two balls are traveling north and south, which are opposite directions. That means that when they collide, their momentum is going to cancel out and become 0 because they're going in opposite directions. So it's like one of their values is negative. So for example, like 8 plus negative 8, that's going to equal 0. So our answer here is going to be choice B. 18. A 1.2 kilogram block and a 1.8 kilogram block are initially at rest on a frictionless horizontal surface. When a compressed spring between the blocks is released, the 1.8 kilogram block moves to the right at 2 meters per second as shown. What is the speed of the 1.2 kilogram block after the spring is released? So it says that initially both blocks were at rest, which means the initial momentum is going to be 0. So we can use the formula of 0 equals m1v1f plus m2v2f, and then plug in. So 0 equals mass 1. I'm going to use the 1.8 kilogram block first. So 1.8 kilograms times 2 meters per second plus 1.2 kilograms times vf, because we don't know that. So this is going to equal 0 equals 3.6 plus 1.2 vf. So subtract 3.6 on both sides. So negative 3.6 equals 1.2 vf. Solve for vf, and we're going to get 3 meters per second. 19. A 20 kilogram mass moving at a speed of 3 meters per second is stopped by a constant force of 15 newtons. How many seconds must the force act on the mass to stop it? So this is another force question. It gives you force, and we just need to backtrack until we find time. So first we plug in the values that we do have into the force equation to find acceleration. So F net equals ma. It tells us that F net is 15 newtons. There's a mass of 20 kilograms, and we need to find acceleration. So acceleration equals 0.75 meters per second squared. Now we need to find time, so acceleration equals v over t. So 0.75 meters per second squared equals 3 meters per second over time, and t is going to equal 4 seconds, which is choice D. 20. What is the speed of a 1 times 10 to the third kilogram car that has a momentum of 2 times 10 to the fourth kilogram times meters per second east? So this question gives us momentum and mass, and we have to find speed. So we plug what we know into the momentum formula and then solve for velocity. So P equals mv. So 2 times 10 to the fourth equals 1 times 10 to the third times velocity, and we're going to get a velocity of 20 meters per second. So that is choice C. Base your answers to questions 21 through 24 on the diagram below, which represents two objects at rest on a frictionless horizontal surface with a spring compressed between them. When the compressed spring is released, the two objects are pushed apart. 21. What is the velocity of the 2 kilogram object after being acted on by 10 Newton seconds of impulse? So this question gives us impulse and mass, and we need to solve for velocity, so we can just plug the values in. So the equation J equals mass times change in velocity. We can use that. So 10 Newton seconds equals mass 2 kilograms times change in velocity, and we're going to get a velocity of 5 meters per second. And that is choice C. 22. What is the total momentum of the two-object system after the expansion of the spring? So remember the conservation of momentum law, which states that the momentum of a system stays the same. It says that both objects were initially at rest, which means there was no movement, and that the initial momentum equals 0. So if the initial momentum was 0, then after the expansion of the spring, the final momentum should also be 0. I know that this might be a little confusing because it says that the objects were pushed apart, which means that they did move, but even if the objects move apart and gain individual momentum, their total momentum as a system still remains 0 because the momentum in one direction cancels out the momentum in the opposite direction. So our answer is choice B. 23. If the 1 kilogram object receives an impulse of plus 20 Newton seconds, what impulse does a 2 kilogram object receive? So, since the momentum of both objects are the same, the impulse of both objects are also the same. So, the impulse of both objects will have the same magnitude, but since they're pushed apart in different directions, one of the values will be negative. So, our answer here is going to be D, negative 20 Newton seconds, because it's the same magnitude, just one is negative. And we're going to skip 24 because it's talking about kinetic energy, which we have not reviewed. 25. At the circus, a 100 kilogram clown is fired at 15 meters per second from a 500 kilogram cannon. What is the recoil speed of the cannon? So the key word here is recoil. So since this is a recoil question, we can use the formula 0 equals m1v1f plus m2v2f, and then plug in to solve. So 0 equals 100 kilograms times 15 meters per second plus 500 times VF. So we're going to solve for VF, and we're going to get 3 meters per second. So that's choice C. We're going to skip 26 because this is just force. It's really easy. We're going to go on to 27. So the diagram below shows a 4 kilogram cart moving to the right and a 6 kilogram cart moving to the left on a horizontal frictionless surface. When the two carts collide, they lock together. The magnitude of the total momentum of the two-cart system after the collision is what? So we know that momentum stays constant, so let's just find the total momentum of the system before the collision, since it'll be the same even after the collision. So for the momentum of the 4 kilogram cart, we can do P equals mv. So 4 kilograms times 3 meters per second equals 12. And then for the momentum of the 6 kilogram cart, it's 6 kilograms times 3 meters per second, which is 18. Don't let this question trick you because the total momentum is not 30. The 4 kilogram cart is moving to the right while the 6 kilogram cart is moving to the left. So they're going in opposite directions. That means that we have to negate one of their momentums before we can add them up. So I'm going to negate the momentum of the 4 kilogram cart, and I'm going to do 18 plus negative 12, and that's going to give us a total momentum of 6 kilograms times meters per second. And remember, since momentum stays the same, if the momentum of the system is 6 before the collision, then it's still going to be 6 after the collision. Now we're going to do some short response. Number 1, Max, who has a mass of 80 kilograms, and his girlfriend Allison, who has a mass of 50 kilograms, are wearing skates and are standing together on a frozen lake. If they push apart and Max has a velocity of 0.72 meters per second in the opposite direction of Allison, then what is the velocity of Allison? So the key word in this question is push apart. So since they were initially just standing there and they were stationary, their initial momentum was 0, which is why we can use the push apart formula of 0 equals m1v1f plus m2v2f. And then we just have to plug in to find Allison's velocity. So for our mass 1, we're going to do 80 kilograms, which is Max, and then he's moving at 0.72 meters per second, plus Allison's mass, which is 50 kilograms, times VF, which we're trying to find, equals 0. So 80 times 0.72 is 57.6 kilograms times meters per second, plus 50 kg times VF, so negative 57.6 kilograms times meters per second equals 50 kg times VF, and VF, or Allison's velocity, is going to be negative 1.152 meters per second. Number 2, stranded on a frozen and frictionless lake, David, who has a mass of 55 kilograms, takes off his 0.15 kilogram shoes. He throws his shoes horizontally directed away from the shore with a speed of 2 meters per second. If David is 5 meters away from the shore, how long does it take before he reaches land? So this question might seem confusing and you may have no clue how to tackle it, but once again, he's initially just standing there, stranded on the frozen lake. He's not moving or anything. So the movement only begins once David takes off his shoes and throws it to propel himself backwards. So this is kind of like a recoil because David's velocity is the result of his shoes' velocity. So we can use the recoil formula, which is once again just 0 equals m1 v1f plus m2 v2f. So 0 equals mass 1, which is David, so 55 kilograms, times vf, plus mass 2, which is the shoes, so 0.15 kilograms, times 5 meters per second. Times 2 meters per second. Now, so 0.15 times 2 is 0.3, plus 55 kilograms, vf. So negative 0.3 equals 55 kg times vf. Vf is going to equal 0.005 meters per second. Okay, so now that we know his velocity, we can solve for the time which it takes him to reach land. So he's 5 meters away from land, and he's moving at 0.0055 meters per second. So we can just plug this into the velocity formula. So v equals d over t, so 0.0055 meters per second equals 5 meters over time. Solve for time, and we're gonna get 909.09 seconds. Number 3, a 0.115 kilogram hockey puck moving 35 meters per second strikes a 0.265 kilogram octopus thrown onto the ice by a hockey fan. The puck and the octopus slide off together. Find their velocity. So it says that they slide off together, so this is a sticky, inelastic collision. That means we have to use the formula m1 v1i plus m2 v2i equals m1 plus m2 times vf. And we just plug in all the values. So for our first mass, we're going to use the hockey puck, so 0.115 kilograms times 35 meters per second, plus the octopus, which is 0.265 kilograms, times 0, because it's stationary, it's at rest, it's not moving, and 0.115 plus 0.265 times VF. So this is going to equal 4.0025 kilograms times meters per second plus 0 equals 0.38 kilograms times VF. And we solve for VF, and we're going to get 10.59 meters per second.